Welcome to the MIDI stepper motor project. Welcome to my musical motors project. Welcome to my musical stepper motors project. Let's split the project down to hardware and software. So right off the bat we have the most obvious hardware, a stepper motor, name is 17 is the model, and we have a stepper motor driver shield along with the A409 drivers. These drivers are hot swappable and they can be swapped out primarily for the reason that driving a motor is a very power intensive process and tends to burn out the chips sometimes. This shield over here makes the circuit into a nice shape, the driver circuit, and adds all the prerequisite components other than the driver itself, and allows easy pin out to connect motors and such. And the shield is connected to this Arduino Uno, which is the brains of the project and runs the program that I'll be talking about in a moment. And this is the general circuit. All of these wires and components here have been replaced by this one shield, so plugging in this shield and plugging in a motor to the pins would be the same as running this circuit. And we finally have a piezo disc that's used as a contact mic to pick up the tiny faint noises made by the movement of the motor in order to amplify them and produce our lovely music. Looking at the programs, we have a map that I have built. This is done over sweeping the frequency of the motor's step duration and step gaps and mapping each gap and duration value to a audio frequency using the spectrum analyzer. And then once that's mapped out and an octave is identified, I play a scale up and down on the motor to hear how it sounds. Once this was successful, which was successful using these functions, a note function that plays the note it's given for the duration it's given, and a pause function that holds all the audio for a specified duration. And we have the frequency receiver script. This is the final version of the script which receives over the serial monitor a note for good measure, a note and whether to turn it on or off. So what this does is, instead of playing a pre-programmed music, which I demonstrated with Super Mario, which sounds best in a stepper motor, by the way, because it sounds like 8-bit audio, this is how the motor drives in the final version. It moves the steps according to a delay which is figured out, calculated, and based on values received through the serial port. And the serial port requires data in a particular schema of x comma y, where x is the number that will be used to figure out the frequency, and y is whether to turn the note on or off. And then we have the MIDI reader Python function. This is the function that is in the end used to drive the Arduino itself. Here I map out every MIDI note based on its frequency using a table that I have calculated, where I've kept track of all of the frequencies of the motor and the corresponding step durations. I figure out the frequencies of the MIDI, each of the MIDI notes, and map them to a step duration in microseconds. And I start off with all motors being turned off, and we have an internal MIDI looping system in my computer. So this is, imagine it as sort of a virtual MIDI port. This allows me to connect a MIDI port to the circuit, a virtual MIDI port, and then I could repeat any MIDI signal either from my own PC or from an external connected apparatus or component or MIDI keyboard or something as such, to forward the signal from there to here and to be played by the circuit. This Python script has two main functions. You have the main outer function, which connects to the serial port, connects to the MIDI device, and then starts listening for information from the MIDI device. When a note is received, it calls the handle MIDI message function, which checks if the note on message is received or the note off message is received. And not only does it tell us what has been received, what has been perceived, it then prints that to the serial port, which is then picked up by the Arduino, and the corresponding sound is played. So in this case, if I pressed middle C, which would be note 60, note 60 has a step duration of 1911 microseconds. So 1911 microseconds. So 1911 followed by 1 for turn on the note would be sent to the Arduino, which would then continuously, as long as a turn off note is not provided, keep stepping the motor every 1911 microseconds, and this would produce a square wave that sounds exactly like middle C. Back in the Arduino script, just to make sure that every time a key is pressed the audio is not interrupted, we use the serial event function. The serial event is an inbuilt function of the Arduino library that asynchronously and without interrupting the active running program receives information from a serial port, processes it, updates data in the registers and in the code without stopping without stopping the function of the primary loop code. So this way a note could be played and another note could then be played, and without a gap between the two, the motor would switch between notes.